Good afternoon, boys and girls. Today we are looking at graphing a quadratic function. So our objective today is to graph a quadratic function. And I guess I should tell you that we are on page 9 of your notes. So you want to turn to page 9 of your note in your note packet. Just wanted to make sure I was saying that correctly. All right, so today we're going to graph a quadratic function. And we're going to graph it on Desmos, which is why I have your Desmos up. So you are going to need to either split your screen or bring up Desmos as well. So the parent function, and the parent function is the function that we transform. Our parent function for the quadratic function is y equals x squared. And you are probably familiar with this, y equals x squared. We call this a parabola. Okay? Now the domain for all quadratic functions is negative infinity to infinity. And what the domain is the possible x values. So if you notice that this x values will go on and on and on forever, and my x values are getting bigger and bigger and bigger, and I can put any x value I want to into this function, and it would all work. It doesn't matter what that x value is, I can put it in there and it will work. So our domain defines our x values. The range defines our y values. Now, if you're looking at the parabola that is already sketched here, can you tell me what is the lowest y value? The lowest y value here is 0. It doesn't go into the negative. 0 is the lowest y value that it goes, and then it goes on and on forever. It goes up to infinity. It keeps going and going and going. It's like the Energizer Bunny. It just keeps going and going. So we say that our range is from 0 to infinity. Or in other words, y is greater than or equal to 0. Notice because it's equal to, there's a bracket here, but with the absolute value, there's always a parenthesis. So where is this parabola increasing? Where are my slopes positive? So we notice that the graph is increasing to the left here. So my y values are getting bigger and bigger and bigger. So it's increasing from 0 to infinity. Where's it decreasing? Where are my y values getting smaller and smaller and smaller? Well, on the left side, I start off big and then I'm coming down to 0. So I'm decreasing from infinity. So I'm increasing from negative infinity, because these are x values, negative infinity to 0. My vertex, this is the vertex. A vertex is a max or minimum point. So this is my vertex, and my vertex happens at 0, 0. Then we have something called the axis of symmetry. The axis of symmetry is an imaginary line that divides the graph into two equal parts. Two symmetrical parts, an axis of symmetry. So we see that our axis of symmetry is the y-axis, and it's always written as an equation, so we're going to say x equals 0. All quadratic functions are continuous. And if we talk about in behavior, as x goes towards infinity, so as x gets bigger and bigger and bigger, what's happening to my y as x gets bigger and bigger and bigger? It too goes to infinity. And as x goes to negative infinity, as my x values get smaller and smaller and smaller, what's happening to my y values? They're going towards infinity. Okay? We're going to talk about solutions later on in the semester. Okay, so what we find from this, we can write what we call a vertex form for a parabola. And that vertex form is y equals a parenthesis x minus h squared plus k, where your vertex is h and k. Your vertex is hk, written as an ordered pair. So A indicates if it's a vertical, shrink, or stretch. Vertical, shrink, or vertical stretch. And it also determines whether or not it is reflected over the x-axis. Your h determines, it's the x-coordinate of your vertex. But it determines how the graph moves left or right. It determines how many units the graph will move left or right. And y, k is the y-coordinate of the vertex. And it determines how the graph will move up or down. Okay? Now, I know this may all seem confusing, so we're going to just do some problems. I'm going to graph the parent function in Desmos and then graph the transform function, which I'm giving you here, and we're going to see how it moves. Okay? So, and I had intended to get rid of that word slope, so just ignore that. It's quadratic. It doesn't have a slope. Okay, so let's start by graphing the parent function, which is y equals x squared. So in Desmos, I want you to go to Desmos, and I want you to type in y equals x squared. And you see we get a parabola. It's a nice, pretty parabola, nice red parabola. All right, now we want to go press enter to get your next graph. And what we're graphing is, go back to your sheet, we're graphing y is equal to x squared minus 3. Okay? So what we're asking ourselves, I think that's what we have, x squared minus 3, yes. So what we're asking ourselves as we do this, the red graph is our original graph. How did this graph move? Did it move left or right, up or down? And you can tell that by its vertex. So how did the vertex move in this graph? And we noticed that it moved down 3 units. Oh, look at that. So we had x squared minus 3. 3 is k. 3 is k, and so it moved down 3 units. So let's go back to our handy-dandy notes. And we're going to note that this is k. Remember, k is outside of the parenthesis. So technically, this can be written as y equals x minus 0 squared minus 3. So in this situation, h is 0 and k is negative 3. Okay? So how was it transformed? So since k is negative 3, we see that it moved down 3 units because k tells us how something moves up or down. What is my domain? Well, my domain is going to be negative infinity to infinity. That's going to be my domain for all of them. What's going to change is my range, because my range will change depending on how it moved up or down. So remember, for a parent function, the range was from 0 to infinity. But for the transform function, my lowest y value is negative 3. So now my range would go from negative 3 to infinity. My axis of symmetry is going to be the x value of that coordinate. So we can see that that is the x value of the vertex. And we can just press Desmos. Is wonderful about telling us exactly what that vertex is, which is 0, negative 3. And this is a minimum value because the graph goes down to a minimum and then it goes back up. So this is a minimum value. And if I were to sketch that on in my notes, I'd go down to -3. I say it crosses the x-axis somewhere between 1 and 2. And I would just sketch it. Okay? Doesn't have to be brain surgery. Doesn't have to be exact. I just want to sketch it. I'm really checking to see its direction, and I'm checking to see its vertex. That's what I'm looking for. Okay? So when we look at the next one, I'm going to rewrite this, y equals 2x squared plus 2. I'm going to write this as y is equal to 2x minus 0 plus 2. So having said that, how do you think this graph is going to be transformed? Do you think it's going to be moved left, right, up, or down? Let's see. So we're going to keep y equals x squared. We're going to keep that one. And then we're going to go to y is equal to 2. Let me just make it bigger. Parenthesis. No, that's not what we have. 2x squared plus 2. Okay? So let me go back for a second. And before I put the 2 in, I wanted you to know something. Notice how the green graph is actually skinnier than the red graph. Okay? So I want you to notice that. And what's causing it to be skinnier is actually the 2 on the coefficient A here is 2. So that's causing it to be skinnier because that is a vertical stretch. So we have 2x squared plus 2. Now, how did that graph move? So a lot of things happen there. If we can get the vertex by simply clicking on it, we see our vertex is 0, 2, which is what we got from the equation 0, 2. So how did it transform? So because A is equal to 2, this is a vertical stretch. So it's a vertical stretch of 2. I don't know why, but every now and then the intercom in my house just comes on and starts playing music. And then it moved it up 2. We see that it moved up 2. Okay? What's my domain? Please, at this point, everyone should say -infinity to infinity. And the range, now my range has changed. What's the lowest y value that I have? The lowest y value that I have is 2, and then it goes up towards infinity. My axis of symmetry is going to be this value. So my axis of symmetry is once again 0, and my vertex, which we found by graphing, was 0, 2. And once again, it's a minimum because it went down. Okay, so let's kind of sketch that. We started at 0, 2, and it's a little skinnier than our previous graph. And that's how we're just going to sketch that right quick. Okay, all righty. Now, the next one, notice, is a little different. We can write this as y is equal to x minus 3. Just as it came on, it went off the same. I have no idea why it does that. Okay, so here, our vertex, we can see that something now is going on with inside the parenthesis. And it's going to move it up or down 0, right? Because k is 0. So let's see what the transformation is by graphing it. We're going to keep y equals x squared. And then we're going to we have to use parenthesis on this. So parenthesis x minus 3, close parenthesis squared. And then you don't have to put the plus 0. I'm just doing it. Okay, so our red is our original. That's our parent function. And green is the new one. So let's find the vertex. What is my vertex here? My vertex is 3, 0. Okay? How did it transform? Did it move it up, down, left, or right? So if we look at our vertices, we can kind of see how it moved. So how did it move? It moved right 3. So my transformation, it moved right 3 units. What is my domain? Please, everyone, go negative infinity to infinity. Now the range, what was the smallest y value that I have? My smallest y value is 0, so my range, it goes from 0 to infinity. My axis of symmetry, so if I sketch this over here on my graph, oh, I didn't mean to do that. I hope I can get it back. It was -3, so it's here. Now, I may not draw this correctly because drawing is not my strong suit. Okay, and it may not look like it, but there's actually an axis of symmetry here. That is very off, guys. Don't laugh at my drawing, because that does not look very symmetrical, but it is. And it's symmetrical around 3. So our axis of symmetry is x equals 3. Do you see a pattern between our axis of symmetry and h? And again, my vertex that we found was 3, 0. This is still a min. Okay? So what we're seeing, notice that when we did +2, the graph moved up 2 when k. When k was -3, the graph moved down 3. So k does what we think it will do. If we add it, k moves it up. If we subtract it, k moves it down. But what's inside that parenthesis actually did the opposite of what we thought. We would have thought by -3 it would have moved it to the left, but notice, no, it moved it to the right. Okay? So what do you think? How do you think the next one will move? Because we should start to see some patterns here. Okay? We should start to see some patterns. So now we're going to graph 1/3 x plus 5 squared plus 1. What do you think is going to happen? How do you think it's going to move? So y is equal to 1 divided by 3, then parenthesis x plus 5 squared. Notice it moved it to the left, plus 1. It should move it up 1. Okay? So now, let's look at that. A couple of different things happen. Notice that my vertex is -5, 1. Okay, so let me go back and rewrite it here. 1/3 x plus 5 squared plus 1. So notice this did the opposite. It's -5, and it moved it to the right, to the left 5. And how did it move it up or down? It moved it up 1. And because A is 1/3, it was a horizontal, I'm going to keep my terminology the same. It was a vertical shrink. Because it's a little bit faster, meaning it's not growing as fast. My domain will remain the same. And my range is going to go from 1 to infinity. And we can see that when we graph it, my smallest value of y is 1. My axis of symmetry is x equals -5. Again, notice the relationship between the axis of symmetry and the vertex. So when I sketch my graph, I have a vertex at -5, +1, and it goes like that. I have an axis of symmetry at x equals -5. And that's what my graph looks like. Okay. So what I would like for you to do, I would like for you to pause the video. And I would like for you to tell me the transformation. What is the domain, the range, the axis of symmetry, the vertex? Okay? Pause the video and come back and we'll talk about it. Okay, boys and girls, welcome back. What you should have seen, and I'm going to go ahead and graph it because it did do something. When I realized when I was letting you free on this that we hadn't talked about what happens when A is negative. But once you graphed it, and I type in it incorrectly, y is equal to -3 parenthesis x -4 close parenthesis squared -1. Okay. Now, what we should have recognized before graphing it, that it's going to move right 4 down 1. Okay? You should have also recognized, because this is 3, that this is going to be a vertical stretch. It's going to be a little bit skinnier than the original. Vertical stretch. But something else happened. What else happened? It flipped upside down. So we call that a reflection over the x-axis. So it did all sorts of things here. But notice what didn't change is the formatting. This still moved it right 4, down 1. It still moved right 4 and down 1. My domain remains the same. My axis of symmetry is still going to be x equals 4. And my vertex is going to still be 4, -1. And again, you can just click on there and see it. Now, the range changed because, look, -1 is no longer a minimum. -1 is now a maximum. So it has a maximum. So when it has a maximum, then we say that it goes from -infinity to that maximum value, which is 1. Okay? And to graph this, I'd go to 4, -1. And it's going to be really skinny compared to the other one because of the 3. Okay. Let's do one more together. Again, I'm going to ask you to pause the graph. And I want you to figure out the transformation. Try to figure it out without graphing it. And then graph it and see if your suspicions are true. So remember, this is going to look like y is equal to -1/2 x minus 0 squared minus 4. So pause the video and see and do the transformation without graphing it first. Okie dokie, boys and girls, welcome back. So what you should have seen is that your transformation was a reflection over the x-axis. Reflection because of the negative. Because of the 1/2, it's going to be a vertical shrink. And it moved down 4. It did not move left or right. So my domain, please everybody, please say this. My range, okay, so let me go ahead and graph what this looks like. So I'm going down -4. And it's going to be a little bit fatter. So my range now, this is now a maximum. So when it's a maximum, my range is going to go from negative infinity to -4. The axis of symmetry is going to be x equals 0. My vertex is going to be 0, -4. Okay, and we're not going to, I didn't mean to have all of that on there. Okay, so let's see if I'm correct by graphing it. So we have y is equal to -1 divided by 2. And then we put our parenthesis, x squared minus 4. Nope. I didn't mean to put a parenthesis there. Minus 4. There we go. Okay, and what did we get? Where is it? Okay, I got something wrong here. I got a comma instead of an equal sign. Well, they didn't like that. Y is equal to, there we go. All right, notice that it reflected over the x-axis. It went down 4, and it's a little bit fatter, just like we said it would be. Okay, boys and girls? So that is how we graph a quadratic function, and we will practice this more in class. You guys have a great day.